Welcome. We're going to be looking at tangent, cosecant, secant, and cotangent, or the other trigonometric functions. Now, since we did so much legwork way back in the session 1 video, we can actually use this very familiar table to kind of help set up a more robust table for all of the special angles and radians that are most commonly referred to in the unit circle. So, let's take a look here. Now we're going to begin where we have with something familiar. This is the first quadrant table where we had 0 radians and 0 degrees, and then we went to 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now the radian equivalent of 30 degrees would be pi over 6, and then pi over 4, and then pi over 3 for 60 degrees, and pi over 2 for 90 degrees. If you would like to see these derived, please go back to session 1 and see how we got to these fractions for the radian measurements in the first quadrant. Now, the sign goes 0, 1, 2, 3, and then back to 1 here. And our denominators are all over 2. And the numerators are all rooted. And we don't root the 1 because the square root of 1 is 1. And so this is our sine table here, and the sine correlates to the y values on the unit circle, because sine is opposite over hypotenuse, and since the hypotenuse is 1, y divided by 1 is just y. The cosine is related to the x variable, thanks to SOHCAHTOA, which is our adjacent over hypotenuse, and hypotenuse is 1. And if we look down along the sine column, we can go up, starting with 0, and then going 1/2, square root of 2 over 2, square root of 3 over 2, and then at 1. So by going down this column and up this column, we've got our sine and cosine. Now tangent is y divided by x, so we take our y value and divide it by our x value, we get the tangent value. So 0 divided by 1 is 0. And this divided by this is square root of 3 over 3. For the full ways to derive these, please go back to the session 1 videos. This divided by this is 1, so the tangent at 45 degrees is 1. The square root of 3 over 2 divided by 1/2 is square root of 3. And 1 divided by 0 is undefined. I'll abbreviate that with undefined. Now I'm going to look at cotangent, which is x over y, and I'm essentially going to copy that way over here, but go in the other direction, starting with 0 from the bottom instead of the top. And this would be square root of 3 over 3. This is 1. This is square root of 3. And then this here is undefined. So cosecant is going to be the reciprocal of sine, and secant is going to be the reciprocal of x. So what I'll do is just take my sine and take the reciprocal of that, and the reciprocal of 0 over 1 is undefined because that would be 1 divided by 0. This is going to be 2 because that's reciprocal of 1/2. The reciprocal of square root of 2 over 2 is 2 once fully simplified, and again for full walkthroughs of these, please go back to session 1. And this would be 2 over square root of 3, which then would be 2 square root of 3 over 3 fully simplified. And my cosecant at 90 degrees will be 1, because that would be 1 over y, and 1 over 1 is just 1. Now, if I get this column right, I can then go up this column, starting with undefined at the bottom, and then moving to 2, square root of 2, 2 square root of 3 over 3, and then finally 1. So this has been done now. This is the 3rd time in video I've done this, and hopefully you've done it too. But our next job is to take what's on this page and copy it into this more complete unit circle. Now, the reason why I want to focus on this design is because this is a one-stop shop of every single degree and radian that's important in the unit circle, but it not only gives us sine and cosine, but it also gives us the other 4 trigonometric values. Now, let me tell you a couple things about how this is created. This is created from the idea that this over here is going to be our 0-degree mark. And then this right here is our 30-degree mark. Now this kind of has to travel over across here to this 45-degree mark. And then if we scroll up a little bit, this here is going to go to here, which is going to be our 60-degree mark. And then this is going to go here, which is our 90-degree mark. Now, I have worked with this software here to make these videos for a while. And what happens after you get a certain amount of marks on this worksheet, what happens is that the computer can't handle like that many annotations per page. So what I have is I have this document in another form and it's filled out. So what I'm going to do is show you how you should fill this out, and you should also pause the YouTube video to fill it out for yourself. And then I'll show you how to make it really great to get from one side to the next. And I'll use a highlighter with that. So here's the full first and second quadrant easily visible, filled out. And the reason why I want you to pause the video and fill out only part of this is because I want you to see the symmetry. If you had to replicate this, how would you do so in a very methodical and efficient form? Now, there must be a reason why at the top of this handout that I've given you that you had to only do the first quadrant. And the reason why the first quadrant is so critical, because what I'm going to do is I'm going to mark this area right here. If I mark this area, then everything in this northeast corner is the first quadrant. You see you've got your 0 degrees, your 30 degrees, your 45 degrees, 60 degrees, and 90 degrees. Now you can get all of those values from the table that you've already built. So you'll also notice that in green I've kind of highlighted these important angles. But if I take a look at, let's say, the 45-degree mark here, there's some pretty cool symmetry going on in the second quadrant. So take a look at this yellow swab I've made here versus the yellow here. Notice that the sine, cosine, tangent, and all the reciprocal functions, the cosecant, secant, and cotangent, notice how they're all the same over here with one little exception. You'll notice that in the second quadrant, these values of x are negative. So here we have a negative x and a y. So the best way to make this chart is to copy the first quadrant, since all the values of x and y are positive, and then take whatever's on the right and copy it to the left in that section, and then apply your negatives for just the x. So let's take a look at this. You can see this is the these are across from each other. This is 60 degrees, and this is also one of those multiples of 60 degrees, and you can see that from the denominator of the radian. This is pi over 3, this is 2 pi over 3. Notice how all that's in green is the same over here, with the exception that the x is negative. And we can do that too with this 60-degree angle here, and the 60-degree angle then gets copied over here. And again, you'll notice that all of the 6 trigonometric values are the same from here to here. It's just that the x values are negative. Now, going from the 90-degree measurements might just take a little bit of common sense. So if we look at the 0 and the 90, this was given to us in the problem. But take a look at this over here at the 180-degree mark. At the 180-degree mark, you'll notice that it is the same all the way through here, except my x's, instead of being positive ones, are negative ones. Please do not put down negative 0 or negative undefined. I will mark those wrong. Negative 0, negative undefined is not fully simplified. Just like 1x or, 6/3. Those need to be simplified. So you can kind of see, too, if you forget about what they are, you can just kind of like look over here. This at the 180 degrees is the point. -1 comma 0. So that'd be -1 on my x and 0 on my y, and then you can just kind of run with the rest of these. If you know x and y, you should be able to figure out the rest. So how do we handle moving from like first quadrant to second quadrant was pretty great, but then how do we do the lower quadrants? Well, I'm going to go to a smaller view here. Let me go and change my view to 140. If I do that, I should be able to see everything okay. All right, cool. Probably a little bit smaller, sorry. Maybe 120. Much better. Okay, so you can see the symmetry between all of the colored sections so far, but there's still more symmetry to go. That's the best part about this. There's still more symmetry. Like if you could take a look at the, we started off with the yellow sections here. Well, there's another yellow section down here. And notice that all of the sine, cosine, tangent, and reciprocal functions are all the same as the yellow up here, with one little difference. The difference is that all the x values and y values are negative. But be careful, because you just might be tempted to slap negatives on all 6 of these. Tangent and cotangent are positive. And the main reason why tangent and cotangent are positive is tangent is derived by, on the unit circle, the y over x. And if y and x are both negative, then negative divided by negative is positive. Same thing with cotangent, since that's x over y, and so far negative x over negative y, 2 negatives divided by a positive, that makes tangent and cotangent positive in the third quadrant. Well, do you see other symmetries? Yeah, sure. Look at this one here. As if you folded the top half of this worksheet along the x-axis, it would like make this blue mark copy onto this blue mark, with all the x's and y's being negative and tangent and cotangent being positive. You can kind of see where the color coding is going to keep working here. And I'm going to leave this white because I can copy this down here and see that the x's and y's are both opposites of what they once were, and we're not going to put -0 and negative undefined. So we have -1 and -1 compared to this up here. And again, if you forget about the pattern, you can just treat 270 degrees like the value that it is, which is 0, -1. And that gives you your x and your y, and you can derive the rest. Okay, so you see these colors over here. Do you see which one is going to match green to the other 3? And it's this one. You can either think of that as folding. You can fold along the x-axis or the y-axis. See, the y-axis will travel from 4th to 3rd quadrant, and folding along from the 4th quadrant along the x-axis gets us to the 1st quadrant. Notice our radians have the same denominator. See, all denominators of 3's in the green zone. And all of these values in the 4th quadrant have a positive x, notice cosine's positive, and a negative y value. And finally, we're going to get to some colors here. We're going to, I should probably color that purple just so you can see the symmetry. And let's get to the blue. You can see the blue section here. And you can see the yellow section here. Now, you can pause the video at any time and copy all these down. Once you've done so, you have your master unit circle for the rest of the semester. In the face-to-face classes, I make students memorize these for paper, pencil, and face-to-face tests. For any kind of exam that is part of the take-home, you should have this in front of you. So, another thought to think about here is that you may want to, since this is on the bottom half of a worksheet, if you want to get a clean copy like this picture, which is, you know, as you see it right in front of you, like taking up a full 8.5 by 11 sheet of paper, I will have these charts available in blank form from my Moodle page. So this brings us to the first question that we can ask of you in this homework section, is just use the chart on the previous page to find the exact value of each expression. Now, if you're going to pay attention to what the book wants you to do, it wants you to derive all of these. But since we did all of that work back in session 1, we don't need to. We can just use our previous work to kind of make these nice and simple problems for us to figure out. So we look up 5 pi over 6, and we see that on the unit circle is going to be, at the tangent value, negative square root of 3 over 3. We look up 11 pi over 6, which is at 330 degrees, so that's negative 2 for the cosecant value there. The secant value is square root of 2. The cotangent value at 5 pi over 4 is 1. Now, these next two are going to be a little bit of work, and that's because 7 pi over 3 is 1 full revolution around the circle. So I can think of that 7 pi over 3 like 2 pi plus a remaining radian over 3. Well, since I need a denominator of 3, 2 pi is 6 pi over 3, and that gets me almost to 7, so this would be 1 pi over 3, or just pi over 3, and the tangent of pi over 3 is the square root of 3. The secant of 11 pi over 4 is the same thing as the secant of going around the unit circle once and then landing on where we need to be. So I need to have some kind of denominator of 4 over here, so if I go around the unit circle, that gives me 8 pi over 4. So 2 pi plus whatever to get to 11 is 3. So we have 8 pi over 4 plus 3 pi over 4, and if I want to go to the secant of 3 pi over 4, that's negative square root of 2 in the second quadrant. Now, these two are just straight easy to answer. So the cosecant of 150 degrees is 2, and the cotangent of 210 degrees is 3. And these are all really straightforward and easy, thanks to all the hard work you did in session 1 many weeks ago, and also in the unit circle that you just filled out.